these represent NASA's research satellites, and it doesn't include those of our interagency and international partners, all of whom contribute to the body of knowledge. But that the key point on this is not only that we have a lot of satellites looking down and studying the Earth, but especially from the point of view of being interested in the poles, which are a very poorly sampled part of the Earth and hard to explore region. Most of the satellites do a very good job at covering the poles. The overwhelming fraction of our satellites are in what we call a polar orbit, so they go essentially over each pole 14 to 16 times a day. It takes about 90 minutes or so, 90 to 100 minutes for the satellites to orbit the Earth. So that means that we've got very good coverage over each pole, and they're moving quickly. They move about 7 kilometers a second in that orbit. So it means that we have the opportunity to view the Earth's poles. Actually shows some historic imagery from the Antarctic, late January, February, March, and then working its way into April. Some significant changes associated with that. And if one thinks about it, without the perspective of satellites, it would be very hard to, it'd almost be a matter of luck to be able to see it, because you'd have to have people there in the right place at the right time long enough. But one of the great things about the satellites in these kinds of orbits is they're there, and one can see routinely. So we're now in the position of being able to document these kinds of things and in a quantifiable way, and ultimately build models that will try to help us understand why do these things happen, how often might they happen again in the future, and what the relationship of that future to changing environmental conditions may be. This is sort of pieced together with a variety of data. Actually, very little of that would have been our data. We get radar data that provides information about the motion of the ice, and the scientists went and put it together. We were able to turn it into a map of ice flows. And usually we don't think of ice as flowing. You think of ice as being something that's static, but the ice really does flow. It flows slowly, but it does move, and the rate at which it moves becomes important, because if the ice moves and it gets closer to the coast where there's warmer water, they can help melt it. You've got other opportunities for melting. So one really needs to understand the dynamics of the ice-covered areas like Antarctica, and we now have the capability through the scientists working with all the different data that they can get to be able to do that. And again, I emphasize the overwhelming fraction of the data that we used was not data that we generated, but it's data that others generated, made available, and our scientists utilized. And one can actually look at the black loss ice mass in Antarctica and see towards the latter part, it's very stable. There's variations from year to year, and so when you look at it over almost 10 years, it's 90 gigatons per year, but then you see that the spatial patterns are variable ice mass loss. And what the scientists are doing with the data, and there's other approaches used too, to try to calculate how much ice mass is being lost from Antarctica. This is Greenland covering about 10 years. Actually, in the interior, you get little bits of increase. And again, this is the kind of thing where, in the absence of satellite data, I don't know how one can even begin to comprehend the nature of the changes. We really are watching what's going on in one of the most rapidly changing and vulnerable parts of the planet. And then there are certain things, like I think in terms of, say, the sea ice melt, in some sense it's easier to melt ice than it is to form it. So it's actually hard to go back the other way. And so like for sea ice, we've seen a lot of where you used to have multi-year ice, now we're looking at one-year ice.